Welcome to today's math lesson on Chapter 9, Section 7, entitled Volumes of Prisms. Volumes of Prisms. A long time ago, we talked about area of different shapes, including prisms, and we're going to go ahead and talk about the volume of prisms in this lesson. Now, this lesson is a little bit different than what we're used to in most classes. Today, we're going to be learning online, and you'll be able to follow this video. The benefits of this is you guys can pause, you guys can rewind, you guys can go over any examples that I go over in class. But we're also going to be using a couple of different tools. We're going to be using this PowerPoint presentation as well as this paint program where I can use this blank screen and I can actually write stuff to you guys, stuff like hi, alright, or we can also do stuff like math. Cool stuff, right? I'm sure you guys are all super excited to get back to learning about math. So let's go ahead and talk about volumes of prisms. All right, so a long time ago, we talked about area. And area is different than volume. I want you guys to go ahead and write down this definition for volume. The volume of a closed three-dimensional figure is a number of cubic units it contains. Now that means something. I know that means something. But we need to go ahead and look and get a better application of what that really means. All right, so let's go ahead and talk about the difference between area and volume. Remember, a long time ago, I kept saying that area is square area. All right, what that meant is that area has square units. So, for example, if I had a shape like, let's say that this is supposed to be a rectangle. Oh, terrible rectangle. All right, and I wanted to find the area of this rectangle that had, let's say this had a height of 3 inches, and it had a width of, let's say, 3 inches as well. All right, you would find the area of this by multiplying the area of a rectangle was base times height, which in this case was 3 inches times 3 inches, which gave us an area of 9 inches squared. All right. Remember, we said that area is square area, which means that there are 9 little squares on the inside of this whole rectangle. Now, today we're going to be talking about volume, and volume is a little bit different. Volume is terrible writing with this pad. All right, volume is a little bit different, so we need to go ahead and kind of get used to the differences between these things. All right. Now, if area was the space on the inside of 2 dimensions, volume is going to be the space on the inside of a 3-dimensional figure. So here's an example right here. The area would be the blue section. Now, just the blue section, just how much square centimeters would be on the inside of this blue section. The volume is going to be everything on the inside of this cube. Now, we can think of volume kind of like the house that you're in right now, that we're all kind of quarantined in right now. The volume is how much space that you have inside your entire house, where if I ask you how much space you have, you might consider just the floor, but technically you also have the wall height as well. So volume of a cube is going to be not only the area on the base, but also the base times the height. And that brings us to our first formula that you guys definitely need to write down. The volume of a prism is the area of the base times the area of the height. And here we have our key formula for us to write down. The volume of a prism is the area of the base times the height. Now this B is capitalized because it's the area of the entire base. So let's go ahead and get this terrible writing pad out again. All right, let's go ahead and try to figure out, well, where is the base? All right, let's say I have a cylinder. All right, coming across here, dot, 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 dot. All right, now if this was a cylinder, pretend that this is a circular top and a circular bottom right here. The cylinder has 2 bases. All right, this guy right here would be one base, and this guy right here would be another base. There are two bases in this cylinder. Now the bases will always be on the opposite sides of each other. All right. If I had an example like this where I had a rectangular prism, it's kind of standing like this, where I have, this is going to be a rough drawing day for me. Boom. Boom. Pretend that's terrible. Let's go ahead and let's get ahead and delete this thing. All right. All right. Let's say that we have a. Let's try this one more time. Let's try a triangular prism. So I draw one triangle here, one triangle right here, and I connect the lines going up here. All right, that's better. All right, where are the bases? Well, I might have one base. I might have one base up here on this top and the other base down here. Now these bases are across from each other. If I wanted to find the volume, it would be the area of one base. The volume is going to be the area of the base times the height. Okay? That makes sense? So let's say that this base here on the bottom has an area of, let's say, 20 square inches. And the height is, let's say, 5 inches. The volume is just going to be the area of the base is 20 square inches, and the height is going to be 5 inches. Now if we multiply these together, we have 20 times 5. 20 times 5 is going to be 100. And if we have inches squared times inches, so inches squared times inches, we know that inches squared times inches is going to be inches cubed. Now how is this different than area? Well, area we said was always going to be square area. Go ahead and say that out loud at home. Area is square area. But when we have volume, it's always going to have a 3 as an exponent, which is going to make volubic is always going to be something called cubic. Cubic. Click there. Alright. Alright, so we're always going to use cubic units whenever we have volume. So if area is square area, volubic is cubic. Cool? Alright, let's go ahead and get back to the PowerPoint slide. Alright, so that brings us to our first example. What is the volume of the rectangular prism? Well, if we wanted to figure out the volume of this, alright, we can say that the area of the base is going to be the length times width. 2 times 4 is going to be 8. And the height is going to be 3. Now notice, for this rectangular prism, all we had to do was multiply 2 times 4 times 3, and that gave us 24 centimeters cubed. All right, so what we need to be able to do is we need to be able to find the area of the base, which is always going to be length times width, and lastly, we're just going to multiply by the height. So let's go ahead and try the skill check 1. Find the volume of each prism. Find the volume of each prism. So let's go ahead and do this. Example 1. All right. Remember, we have an example where we know that the volume is going to be the area of the base times the height. Now, we need to figure out the area of the space, and the area of the base is going to be 3 centimeters times 3 centimeters. 3 centimeters, 3 centimeters, which is going to give us 9 centimeters squared. Now we can go ahead and try to find our height. Our height in this case is another 3 centimeters. 3 centimeters. 3 centimeters. And our answer is going to be, what's 9 times 3? Very good, very good. 27. And centimeters squared times centimeters is going to be centimeters cubed. All right, because area might be square area, but volume is going to be cubic in cubic units. Cubic. Oh, that was an accident. All right, well, that's cool. There we go. All right, cubic. All right, cool. Our second example is going to be very similar. We're trying to find the area of this base right here. So we have, put this back on our brush. All right, we have volume is equal to area of the base times the height. The area of the base is going to be 12 times 8. 12 times 8 is going to be 96. So 96 centimeters squared. And the height is going to be 6. So we're going to multiply this by 6 centimeters. Now, I am letting you guys use calculators this chapter. So 96 times 6 is going to be 576 centimeters cubed. Cool? Cool. Let's clear this guy out. Alright. Next, alright, one thing we should always talk about is the bases of a prism are always going to be parallel and congruent. Parallel, meaning they're across from each other, they face the same direction. Congruent means they're the same size. So look at this example right here. It says, what is the volume of the triangular prism? Well, this shape's a little bit different. We can't just multiply all three of these numbers together like we would a rectangular prism. We need to find the area of the base times the height. Now, these triangles are the bases, so the area of one triangle is going to be base times height divided by 2. The 8 times 3 is going to give us 24, divided by 2 gives us 12. The area of the base is 12 meters squared, times the height of the triangular prism is going to be 10 meters. How do I know that's the height? Well, because whenever I have a shape like this, doesn't matter if it's laying on its back or going straight up, this is going to be the height. The height's always going to be perpendicular to the bases. Sound good? Cool. 12 times 10 is 120, and volume is going to be cubic. Alright, so how would I find the volume of this shape right here? Well, I need to find the area of the base. 9 times 10 is 90, divided by 2 is 45. 45 times 15 will give me my area of my base times my height, and 45 times 15 would give me 675 meters cubed. Sound good? Alright. Well, that concludes our lesson. I hope you enjoyed it. Again, main things you want to go ahead and recap. Alright, the volume is going to be all the space on the inside of a three-dimensional figure. Alright, we should also remind ourselves that volume is the area of the base times the height for any prism. Sometimes the bases might be rectangles and easy to find. Sometimes they might be triangles and other shapes. We want to find the area of the base first and then multiply it by its height. Alright, your homework's going to be assigned on Google Classroom. Good luck.